Now let's talk about the trigonometry ratios of angles. And first, let's take a quick recap on the right angle triangle. So if you recall from our discussion on the right angle triangle, it's a triangle that has one side of 90 degrees. So when you have a triangle and one of the angles measures 90 degrees, then we'll call that triangle a right angle triangle. So to define the relationship between the angles and the sides of a right angle triangle, we make use of something called SOHCAHTOA. So SOHCAHTOA is an acronym where S represents sine and OH represents opposite and hypotenuse. So sine theta is equals to opposite over hypotenuse. Then cos theta is equals to adjacent over the hypotenuse, and tan theta equals to the opposite over the adjacent. So let's define the size of a right angle triangle. When you have a right angle triangle, so you have one side that measures 90 degrees. So let's take a look at another side and let's call that angle theta. So if you call here theta, the side that is directly opposite that angle is referred to as the opposite. Then the other side that lies adjacent to the angle is called the adjacent side. And while the longest side of a right angle triangle of a triangle general is called the hypotenuse. So imagine now that in our right angle triangle, that the angle theta is indicated to be this portion over here. So in this case, the side opposite that angle will be my opposite. So here becomes my opposite, and the other side becomes what? My adjacent side. And while the longest side of my right angle triangle becomes my hypotenuse. So for the sine of this angle here, the sine theta is given as the opposite over the hypotenuse, the cosine is given as the adjacent over the hypotenuse, and the tangent is given as the opposite over the adjacent. So let's look at how this plays out. So here we are told to calculate the value of sine theta, cos theta, and tan theta in the figure below. So we are given a right angle triangle. As you can see, one of the side here is 90 degrees, which makes it a right angle triangle, and we are given that this angle to be theta. So let me sketch that out so you can see it clearly. So you have this angle here called theta, and you have a right angle here, and I told that the length of this place is 5, length here is 12, and the hypotenuse is 13. So the first thing you want to do is you want to label the side. So the side opposite to the angle theta is called my what? My opposite. Then the side adjacent to the angle is called my adjacent side, and the longest side is called what? The hypotenuse. So I know that my opposite in this case is 5, my adjacent is 12, and my hypotenuse is 13. So now what is the value of sine theta? Sine theta we have told is what? Is opposite over the hypotenuse. So in this case, what is the opposite? The opposite is 5, and what is the hypotenuse? 13. So sine theta is 5 over 13. How about cos theta? Cos theta we are told is equals to what? The adjacent over the hypotenuse. Now what is the adjacent? The adjacent is 12, and the hypotenuse is 13. So cos theta is what? 12 over 13. And what is tan theta? I told that tangent is equals to what? The opposite over the adjacent. And what does that give us? So the opposite is what? 5, and the adjacent is 12. So the tan theta is what? 5 over 12. So now I want us to quickly perform an operation. And what I want us to do now is to find sine theta divided by cos theta. So now what is sine theta based on what we have calculated? I've got this sine theta to be 5 over 13. So we have 5 over 13 divided by, and what is our value for cos theta? 12 over 13. So what does this become? So this becomes what? 5 over 13 times 13 over 12. And that becomes what? 5 over 12. And what is 5 over 12? We see that 5 over 12 is what we got when we evaluated what? Tan theta. So therefore we can conclude that tan theta is the same thing as having what? Sin theta over cos theta. So this is a very important relationship to memorize or to know, that tan theta is the same thing as what? Sin theta over cos theta. Let's take a look at another example, and here we are told that if tan theta is given as 8 over 15, we should find sin theta plus cos theta over cos theta in the bracket 1 minus cos theta. So to get started, Let's try to sketch this out in the right angle triangle. So if I draw my right angle triangle like this, and this is my right angle here, and I call this angle here theta. Tan theta, as I know, is what? Tan theta is what? Opposite over my adjacent. So therefore, I know that my opposite in this case will be what? 8, and my adjacent is 15. So the opposite side is what? 8, and the adjacent side is 15. So now for my hypotenuse theorem, I can calculate the length of my hypotenuse for my Pythagoras theorem rather. So if I call here A, I know that what? A squared is equals to 15 squared plus 8 squared. I know that A squared will be equals to 15 squared is 225 and 8 squared is 64. So A will be equals to the square root of 289 and that is equals to 17. So the hypotenuse is equals to 17. So now I know the opposite to be 8, I know the adjacent to be 15, and I know the hypotenuse to be what? 17. So I can find the value of sin theta and cos theta. So I know that sin theta is what? Sin theta is my opposite over my hypotenuse. And what is my opposite in this case? My opposite in this case is 8. And my hypotenuse is what? 17. So sin theta is 8 over 17. What of cos theta? Cos theta is given as adjacent over the hypotenuse. And what is my adjacent in this case? 15. And what is my hypotenuse? My hypotenuse is 17. So sin theta is 8 over 17 and cos theta is 15 over 17. Now I can try to evaluate what I'm asked to evaluate. So I'm told to find sin theta plus cos theta. Sin theta are found to be 8 over 17. Then plus cos theta are found to be 15 over 17. Then all over cos theta are found to be 15 over 17 into bracket 1 minus cos theta are found to be 15 over 17. And this becomes 8 plus 15 gives me 23 over 17. Then over, I have 15 over 17. And when you find the LCM and try to simplify this, 1 minus 15 over 17 gives me 2 over 17. So that becomes 23 over 17 divided by 15 times 2 is 30 and 17 times 17 gives me 289. So this is same as say 23 over 17 divided by 30 over 289. And that becomes 23 over 17 times 289 over 30. 17 here goes 1 and 17 into 89 goes 17. 23 times 17 gives me 391 over 30. And if you convert this to decimal, this becomes 13.033. So if tan theta is equals to 8 over 15, then the value of sin theta plus cos theta over cos theta into bracket 1 minus cos theta is given as 391 over 30 or 13.033. Now let's look at another example. And here we are told that a ladder of length 6 meters rests with its foot on a horizontal ground and leans against a vertical wall. So the first thing I'd like to do is to sketch out this problem. So you have a vertical wall. Now you have a ladder that leans on it, and this is the ladder over here. So you have a ladder leaning on the vertical wall. And we're told that the length of the ladder is 6 meters. So the length of the ladder is 6 meters. We're told that the inclination of the ladder to the ground is 80 degrees. So the angle that the ladder makes with the ground is what? 80 degrees. We're told to find one, the distance of the foot of the ladder from the wall. So now this is the wall over here. So we're told to find the distance from the foot of the ladder here to the wall. So let me call that distance x. So now if you can see, I have one angle over here, then I'm looking for this length over here and I know the hypotenuse. If I label here, this side becomes my opposite and here becomes my adjacent and here becomes my hypotenuse. Now what I'm trying to look for is the adjacent side of this right angle triangle. And I ask myself, what equation or what relationship relates the adjacent side of a triangle to the hypotenuse? And I'll see that is what? Cos. So I know that cos theta is equals to what? Adjacent over the hypotenuse. So now I can write that cos, in this case my angle is what? 80 degrees, is equals to my adjacent side is what I'm looking for, then over my hypotenuse side is what? Is 6. So my adjacent, which I've said to be length x, is equals to 6 times cos 18. And when you punch this into your calculator, you get 1.04, or they take to one decimal place, 1.04 meters, which is equals to 1 meters to one decimal place. So when you are punching cos 18 to your calculator, make sure that your calculator is set to degrees as in DEG, because it's when it's set to degrees that you get the right answer. So now let's look at the B part of the question. The B part tells us to find the height above the ground at which the upper end of the ladder touches the wall. So now I'm told to find the height from this point where the ladder touches the wall to the floor. So let me call that height h. So as I can see now, I know the hypotenuse side and I'm trying to find the opposite side. So what relationship connects the hypotenuse to the opposite? I know that is sine. So I can write that what? Sine theta is equals to opposite over the hypotenuse. And my opposite, my sine theta in this case, theta is what? 80. So sine 80 is equals to my opposite is the height of the wall h over my hypotenuse, which is the length of the ladder, which is 6. So h will be equals to 6 times sine 80. And when you punch this into your calculator, you get 5.9 meters to one decimal place. So now let's look at a concept that is applicable to right angle triangles only, and that is called the Pythagoras theorem. And I know we have used it in one previous example we solved, but let's try to just look at it in details now. So what is it telling us? It's telling us that if you have a right angle triangle, that the square of the hypotenuse, in this case the hypotenuse is given as length t, is equal to the square of the sum of the square of the two other sides. So if it's called this side A and we'll call this side B, and we'll find their square. If we sum their square together, is equal to the square of the hypotenuse. Now there is an interesting derivation to this, but I'm not going to go through that. The only thing you need to know is that the square of the hypotenuse is equal to the sum of the square of the two other sides. So how does this play out? So here we are told to find the missing lengths in the following right angle triangles. So here in the first one, I told that the hypotenuse, as you can see, the longest side or the side opposite to the right angle triangle is 13. I told that this side here is 5 and this length here is a. So from the theory, I know that what the hypotenuse squared, which is 13 squared, must be equals to the sum of the two other sides, must be equals to a squared plus 5 squared. So if I bring this over here, I can have what? X squared is equals to 13 squared minus 5 squared. So a squared is equals to 169 minus 25. So x squared is equals to 144. And to find a, I just find the square root of both sides, and I have a is equals to 12. Now for the other example, I'm told to find this length over here x, and as I can see, the x here represents the hypotenuse since it's the longest side and is opposite to the right angle. So I can write that what? That x squared is equals to 7 squared plus 6 squared. So x squared is equals to 7 squared is 49 and 6 squared is 36. So x squared is equals to 85. So I find the square root of both sides and I have the value of x to be equals to 9.22. So this pretty much wraps up what you need to know in relation to Pythagoras theorem. So now let's look at some special types of right angle triangle. And first I'm going to look at a 45-degree right angle triangle. So as we've mentioned before, in a right angle triangle, one of the angle must be 90 degrees. And if one of the angle is 90 degrees, I know by default, since the sum of a triangle must be equals to 180, that the sum of the two other angles must be equals to 90 degrees. So now in a 45-degree right angle triangle, the 90 degree that is to be shared between the two other angles is split equally. So you have 45 degrees here and 45 degrees here. So what you have here is an isosceles triangle, because now I have two angles that are equal. So if we call this length 1 and we call this length over here 1, then from Pythagoras theorem I know that the hypotenuse squared, and let me write that as h squared equals to 1 squared plus 1 squared. So h squared will be equals to 2 and h will be equals to the square root of 2. So this length over here will be square root of 2. So if we know this relationship for 45-degree right angle triangle, how is this useful? So let's assume I have a right angle triangle now, and I'm told that here is 45, so this is a 45-degree right angle triangle, and I'm told that the length here is 5, and I'm told to find the other lengths of the triangle. So now I just have to ask myself, like when I add 1 here, I add here a multiple of 1, and I add here a multiple of 1 of root 2 times 1. So here, since this is an isosceles triangle, the length here also will be equals to what? 5, and the length at this side will be equals to what? 5 times what? Root 2. So you just multiply the one side that you know by the other values that are here. So when if you know this property, you do not need to start trying to solve from the scratch or anything. You can easily deduce the other sides simply. And now let's talk about another special right angle triangle, and that is the 30-degree and 60-degree right angle triangle. So in this triangle, you have one of the angles here to be 30 and the other to be 60, and you have the right angle here to be 90. So what it's telling us is that if you have this kind of triangle in which you have 90 degrees here and here is 60 degrees and there is 30 degrees, that if the length of the hypotenuse is 2 and here is 1, the length of the adjacent will be what? Would 3. So as an example now, if I have this kind of a triangle and I'm told that here is 30 degrees, I'm told that here is 60 degrees, I know that if the length here is 10, that the length here is going to be 5, and the length over here is going to be what? 5 root 3. As simple as that. So that is what the usefulness of knowing this special right angle triangle is for, to make calculations faster. So now let's talk about the values of some special angles. So here I told that sine 0 is 0, sine 30 is half, sine 45 is 1 over root 2, sine 60 is root 3 over 2, and you can read off the values of others, because 0 is 1 and so on. So I would suggest that you try to memorize the values of these special angles, because by memorizing them it will make your calculation faster and they come in really handy. So you should know the values of sine, cos and tan of 0, 30, 45, 60 and 90 degrees. Now let's shift to the idea of quadrants. So let's talk about our Cartesian plane. So this is our Cartesian plane over here. I want to talk about angle in a point which is 360 degree. So angles between 0 and 360 degree. So when I move from, say, this point which is 0 degree to this point over here, I can see that this is a right angle and the angle here is what? 90 degrees. If I move from this point over here to this point over here, I can see that it's made up of this right angle over here and this right angle over here. So that will be equals to what? 180 degrees. Now if I move on to this section over here, then what do I have? I have an angle from here to this point over here, and that is equals to 270 degrees. And finally, if I move from this point to this point, like I move round, I have what? I have 316 degrees. So the first section, or the first 90 degrees, is referred to as the first quadrant, while the second section over here is referred to as the second quadrant, then the third quadrant and the fourth quadrant. So now we're going to be looking at the relationship between these quadrants. So if I know the value of sine, cos and tangent in the first quadrant, I can invariably know the value of sine, cosine and tan in any other quadrant. So how do we go about this? So there are some special relationships to that. And in the first quadrant, this occurs for values that lie between 0 and 90 degrees. So theta value is between 0 degrees, which is here, to 90 degrees, which is here. So my sine theta is equal to my sine plus of sine theta, my cos theta is equal to my plus of cos theta, and my tan theta is equal to my plus of tan theta. Straightforward. So now when I move on to my second quadrant now, my second quadrant, I know that the angles of theta lies from 90 to what? To 180 degree. So the values of theta lies from 90 degrees to 180 degrees. So how did I convert an angle from a second quadrant to an equivalent angle in the first quadrant? So this relationship explains how to do it. So he said sine theta is equals to plus sine of 180 minus theta. So an example, if I'm given sine 150, now I know that 150 lies in the second quadrant because it is between 90 and 180. So to convert it to a first quadrant, I can write that what? Sine theta will be equals to plus of sine into bracket 180 minus 150. And what would that give me? Plus of sine 30. So now I want you to punch your calculator now. To punch in sine 150, you're going to get 0.5, and to punch in sine 30, you're also going to get 0.5. So the value of sine 150 and sine 30 are the same. So this is the way we do the conversion. Let's assume now that we're supposed to find the value of cos 115. So the relationship here tells me that what? That cos theta for the second quadrant is equal to minus cos 180 minus theta. So that will be what? Minus cos 180 minus 115. And that will be minus cos 13. And that will be what? Minus root 3 over 2, or minus 0.866. So I want you to punch your calculator now and type in cos 150. You're going to get minus 0.866, which is the same thing as minus cos 30. So the same thing applies when you are looking for tan theta. So this is the relationship when you are trying to convert an angle that is the second quadrant to an angle that is in the first quadrant. So now for the third quadrant now, these are the relationship to convert an angle that is in the third quadrant to an angle that is in the first quadrant. So as an example, for the third quadrant, the value of theta lies from 180 to 270. So as a quick example, let me say you want to find the value of sine 200. Now from the relationship, I know that sine theta, if theta is in the third quadrant, is equal to sine into bracket theta minus 180. So that becomes minus sine into bracket 200 minus 180, and that becomes minus sine 20. So what this means is that sine 200 is equivalent to minus sine of 20. So this explains the other relationships also, and this explains the relationship when theta lies in the last quadrant. And for the last quadrant, I know that it lies on the value of 270 to what? To 360. So for instance, if I'm told to find the value of tan 300, I know that tan theta is given as minus tan into bracket 360 minus theta. So I know that tan 300 is the same thing as minus tan open bracket 360 minus 300. And what does that become? That becomes minus tan 60. So tan 300 is the same thing as minus tan 60. So let's look at some practical or some other examples. So you are told to evaluate the following, and in the first one we are told to find the value of cos 127. Now as you can see, 127 lies in the second quadrant because 127 lies between 90 and 180. So the relationship for the second quadrant is given as what? As cos theta is equals to minus cos open bracket 180 minus theta. So cos 127 is equals to minus cos open bracket 180 minus 127, and that becomes minus cos 53, and the value of cos 53 is 0.6018. So cos 127 is equals to minus 0.6018. So now let's look at another example, and here we are told to find the value of tan 236. As you can see, 236 lies in the third quadrant because the value of theta is between 180 and 270. So this is in the third quadrant. So in the third quadrant, the relationship for my tangent tan theta is given as plus tan into bracket theta minus 180. So what does this become? This becomes plus tangent of theta in this case is 236 minus 180, and that becomes plus tan of 56. And when you do that, that becomes what? 1.4826. So now let's move on to the next example where you are trying to find the value of sine 300. So for sine 300 now, 300 lies in the fourth quadrant because it's between what? 270 and 360. So I know that for my third quadrant that sine theta is equals to minus sine open bracket 360 minus theta. So that becomes sine 300 becomes what? Minus sine of 360 minus 300, and that becomes minus sine of 60, and sine 60 is root 3 over 2, so that becomes minus root 3 over 2 or minus 0.866. And for the last example now, we're told to find the value of cos 60. Cos 60 lies in the first quadrant, so I know that cos theta in the first quadrant is the same thing as plus cos theta. So what would that be? That's just because of cos 60, and cos 60 is what? Half or 0.5. So this pretty much shows us how to convert angles that are in other quadrants to corresponding values in first quadrant. So let's talk about reciprocal trig identity. So we have three basic reciprocal trig identity, and the first one is cosec. So cosec theta is the same thing as 1 over sin theta. Sec theta is the same thing as 1 over cos theta, and cot theta is the same thing as 1 over tan theta. So you have to memorize these relationships between cosec, that cosec is the reciprocal of sine, sec is the reciprocal of cos, and cot is the reciprocal of tan. So let's try to evaluate these values. First, we are told to find the value of cosec 90 degrees. So I know that cosec 90 degrees is the same thing as what? 1 over sine 90 degrees. Now, if we check the table of special angles, sine 90 degrees is 1. So that's the same as saying 1 over 1. So cosec 90 is equals to 1. Now let's move on to the next example. I'm going to find sec 60. Now sec is what? 1 over cos. So sec 60 is the same thing as 1 over cos 16. Now cos 60 is half. So I have 1 divided by half, which is the same thing as 1 times 2 over 1, and that is equals to 2. So sec 60 is equals to 2. And for the last example, I'm going to divide the value of cot 30. Now cot is what? 1 over 10. So that becomes 1 over tan 30. Now tan 30 is given as what? Tan 30 is 1 over root 3. So that is the same thing as saying 1 divided by 1 over root 3. So that becomes 1 divided by 1 over root 3, which is equals to 1 times root 3 over 1, which is equals to root 3. So cot 30 degrees is equals to what? Root 3. And in decimal, that is the same thing as what? 1.732. So this pretty much sums up all you need to know in terms of trigonometry ratios.